Okay, we'll start in about a half a minute. All right, we'll continue with the test 4 review sheet. Test 4 is tomorrow, so later today I'll send a link for the Zoom meeting for the test. Okay, we got to this word problem. In a river, Charles rowed about 2 miles against the current and 4 miles with the current in a total of 4 hours. In still water, Charles can row a boat at 6 miles per hour. Find the speed of the river's current. Okay, so we'll let x be the current speed in miles per hour. And when he's rowing against the current, or upstream, he rows a distance of 2 miles. And in still water, Charles can row a boat at 6 miles per hour. So if he's going against the current, the speed of the boat is 6 minus x. And then we don't know the specific amount of time it takes him to go 2 miles upstream. So we'll use T sub A to represent the amount of time it takes him to go 2 miles against the current. And then with the current, or downstream, he rows 4 miles. So if he's going downstream, the rate of the boat is 6 plus x. And the amount of time, we'll use T sub W to represent that, and the distance is 4 miles. And we're told that the total amount of time to go 2 miles upstream combined with the amount of time it goes to take 4 miles downstream is 4 hours. So that means the amount of time T sub A plus the amount of time T sub W is 4. Okay, so what we want is an equation whose only variable is x. So we're going to use these 3 equations to help us. We'll solve this equation, the one for against the current, solve for the time T sub A. So divide both sides by the rate. Time is equal to distance divided by rate. Solve the second equation for the time, T sub W. This is equal to 4 divided by 6 plus x. And then we substitute into this equation. T sub A is 2 over 6 minus x. T sub W is 4 over 6 plus x. And those add up to 4. So we finally have an equation whose only variable is x. And we want to solve it for x. So what we do is we multiply every term on both sides by the least common denominator. The least common denominator is 6 minus x times 6 plus x. Okay, so when we multiply 6 minus x times 6 plus x, when we multiply that by 2 over 6 minus x, the 6 minus x factors cancel. And we'll be left with 2 times 6 plus x. And then we add that to the next term, 4 over 6 plus x multiplied by the least common denominator. This time the 6 plus x factors cancel, and we're left with plus 4 times 6 minus x. And on the right-hand side, we multiply the least common denominator by 4. When you multiply 6 minus x times 6 plus x, we're going to get 36 minus x squared after we simplify. So I'll just write 4 times the quantity 36 minus x squared. The resulting equation is a quadratic equation. So we'll multiply everything out, combine like terms, and then see what we got. So 2 times 6 plus x is 12 plus 2x. And then plus 4 times 6 minus x is plus 24 minus 4x. On the right-hand side, 4 times 36 is 144, and then minus 4x squared. Combining like terms on the left-hand side, 12 plus 24 is 36, and plus 2x minus 4x is minus 2x. And that's equal to 144 minus 4x squared. And we'll make the right-hand side 0, so we'll add 4x squared to both sides and then subtract 144 from both sides. And when we do that, we get 4x squared and then minus 2x and minus 112 equals 0. Okay, so I'm going to bring extra paper. So I'll continue on another piece of paper. We'll solve 4x squared minus 2x minus 112 equals 0. The first thing we can do is divide every term on both sides by 2. Since 2 is a common factor of everything, divide everything on both sides by 2. We get 2x squared minus x minus 56 equals 0. And then we can use the quadratic formula, where a is 2, b is -1, and c is -56. So we get x equals the negative of -1 plus and minus the square root of -1 squared minus 4 times 2 times -56, all divided by 2 times 2. And then the negative of -1 is 1, plus and minus the square root of 1 minus 4 times 2 times -56. So we're going to be adding or subtracting a negative, which means we're going to be adding, let's see, we'll be adding 448. Is that right? All divided by 4. Is that what you got? Yeah. And then 1. Notice this number, the square root of 1 plus 448, is bigger than 1. So the solution that we want is the one that we get by adding the square root of 449, all divided by 4. Okay, so that's the speed of the current. I'll leave the rest of this for you to simplify. You can just take the square root of 449 and then add 1 to that and divide it all by 4. Okay, let's move on to the next problem. Okay, this one says an arrow is shot upward at a rate of 220 feet per second. Use the projectile formula, h equals 16t to the second plus v sub 0 times t, to determine when the height of the arrow will be 400 feet. Round your answer to the nearest tenth. Okay, there's a typo here. This should be h equals negative 16t to the second. V sub 0 is the variable that represents the initial velocity, and the initial velocity is given to be 220 feet. Okay, so the formula is h equals negative 16t to the second plus 220 times t, and we want to find the value of t when the height h is 400 feet. Okay, so what we do is we just replace h with 400, and we get a quadratic equation in the variable t, and we just solve this quadratic equation. So I'll add 16t to the second and subtract 220t from both sides, and we'll get 16t to the second minus 220t plus 400 equals 0. And we can reduce the numbers if we find a common multiple to divide by. So at least 4 goes into all of those numbers. If we divide every term on both sides of the equation by 4, we get 16t to the second divided by 4 is 4t to the second. And negative 220t divided by 4 is negative 55t. And then 400 divided by 4 is 100. So we can use the quadratic formula. So a is 4, b is negative 55, c is 100. So t is equal to the negative of negative 55 plus and minus the square root of the number negative 55 squared minus 4 times 100, and then all divided by 2 times 4. Okay, so I'll take it a little bit further and then leave the rest of it for you to do. The negative of negative 55 is 55, and then plus and minus the square root of, the square root of this number, negative 55 squared. Well, I'll leave that for you to do with your calculator. I can do the next one. Minus 4 times 100 is minus 1600. And then divide all of that by 8. Okay, let's move on to the next part. So we might not have enough time. We probably don't have enough time to do every single problem. So I'll leapfrog. We'll do a couple and from each. And then if there's more time, we can come back. So in this one, y equals 2x squared minus 8x plus 6. Graph the quadratic functions, find the intercepts, the vertexes, and the equations for the lines of symmetry. Okay, there's a vertex formula for the x-coordinate. Vertex, the x-coordinate is negative b over 2a. So for this one, a is 2, b is negative 8, and c is 6. We just need b and a. So negative of negative 8 over 2 times 2. So we get negative 8, or 8 divided by 4, which is 2. So that's the x-coordinate of the vertex. To find the y-coordinate, we can use this as a formula. Replace every x with 2, so the y-coordinate of the vertex is 2 times 2 to the second minus 8 times 2 plus 6. 2 times 2 to the second is 8, and then minus 8 times 2 is minus 16, and then plus 6. So negative 8 plus 6 is negative 2. So the vertex is an ordered pair. The x-coordinate is 2. The y-coordinate is negative 2. And then the y-intercept. Every y-intercept has an x-coordinate of 0. That's probably the easiest thing to find. When x is 0, the y-coordinate is 6. So the y-intercept is 0, 6. To find the x-intercepts, replace y with 0 and solve for x. So find x-intercepts. So we replace y with 0. 0 equals 2x squared minus 8x plus 6. With an equation, we can divide every term on both sides by a non-zero number. So let's divide every term on both sides by 2. 0 divided by 2 is 0. And then 2x squared minus 8x plus 3 divided by 2 is x squared minus 4x plus 3. And we can easily solve this by factoring. The two factors are x minus 1 and x minus 3. The two solutions are positive 1 and positive 3. Remember that the x-intercepts are ordered pairs. So when you write the x-intercepts, write them as ordered pairs. One of the ordered pairs is 1, 0. The other one is 3, 0. So we can sketch a graph of this. We know 4 points on the graph. The y-intercept is 0, 6. The two x-intercepts are 1, 0 and 3, 0. The vertex is 2, negative 2. So 2, negative 2. The other x-intercept is 1, 0. And by symmetry, we can plot another point. For 6, has to be a point on the line. So So the parabola looks something like this. And then the vertical line of symmetry. So the line of symmetry is a vertical line. So a vertical line in the xy plane is x equals some number. So the vertical line of symmetry passes through the vertex. So the vertical line of symmetry is x equals 2. Okay, let's move on to the section 9.7. It's also graphing quadratic functions. But these, we want to write the quadratic functions in vertex form by completing the square. Okay, so rewrite each quadratic function in vertex form by completing the square, and then graph the function using transformations. Okay, here's the quadratic function in standard form. To get it into vertex form, we factor the coefficient of x squared out of the x squared term and the x term. We leave the constant outside of the parentheses. So factor 2 out of the first two terms, we get 2 times the quantity x squared minus 2x. On the outside of the parentheses, we have plus 4. Then on the inside of the parentheses, we're going to add 0 to x squared minus 2x. But in the process, we're going to create a perfect square trinomial. So now we're just focusing on x squared minus 2x. To get a perfect square trinomial, we take half of -2 and square it. So half of -2 is -1, but when you square -1, you get +1. So we write +1 minus 1. Then in the next step, we keep the perfect square trinomial inside the parentheses. And we have +4 on the outside, but we also have to move this fourth term up here. 2 times -1 is -2, so that means on the outside of the parentheses, we have to subtract 2. Okay, then the vertex form is 2 times x minus 1 squared plus 2. Okay, so now we can identify the vertex. The vertex is the ordered pair 1 for x and 2 for y. Okay, this vertex 1, 2 is above the x-axis. And the leading coefficient, that is the coefficient of x squared, is positive. So the parabola opens upward. We know that we can tell by looking what the y-intercept is. Every y-intercept has an x-coordinate of 0, and when x is 0, the y-coordinate is 4. And then by symmetry, we can find another point on the graph. When x is 2, the y-coordinate should also be 4. And if you want to verify it, you can, remember, use this as a formula for finding y-coordinates whenever you pick an x-coordinate. So when x is 2, 2 times 2 squared is 2 times 4 is 8. 8 minus 4 times 2. 8 minus 8 is 0. 0 plus 4 is 4. So everything works out. So there's our parabola. Okay, let's look at number 2, part 1. Find functions from graphs or descriptions of graphs. Here we just have a description. We're told that the vertex of a parabola is 1, -1, and the y-intercept is the ordered pair 0, 3. So find the quadratic function in its standard form, y equals ax squared plus bx plus c. Okay, so since the y-intercept is 0, 3, that must mean that the value of c is 3. Because when x is 0, the y-coordinate is c, but we're given that information. So the y-intercept is 0, 3. That means c is equal to 3. Yeah, that's a good start. The vertex is 1, -1. So what could we do? We could write the vertex form, y equals a times x minus h to the second plus k. And since the vertex is the ordered pair 1, -1, that means that h is 1 and k is -1. Okay, so we can replace h with 1 and k with -1 and get more information about this function. So we write a times x minus 1 squared plus -1. We'll multiply everything out and see where we are. So first, square the binomial x minus 1. So we have a times the quantity x squared minus 2x plus 1. And then on the outside, since we're adding -1, that's the same as -1. And then distribute multiplication by a, so we get ax squared minus 2ax plus a minus 1. So all we have to do is determine what the value of a is. Okay, so this is the standard form. This is like ax squared plus b times x plus c. Well, we know the value of c is 3, so that must mean that a minus 1 is 3. Okay, so I'll write this more explicitly. This is the standard form, ax squared plus bx plus c. And so c must be equal to a minus 1. But we know that c is 3, so we can solve for a. 3 is equal to a minus 1. And then a is equal to 4. Okay, so now we can write the standard form. if a is 4, y is equal to 4x squared. And minus 2 times a times x. Well, since a is 4, this is minus 8x. And then plus c, which is plus 3. Okay, if you're in doubt, you can verify that this is correct or not just by using the information. All right, let's move on to section 9.8. Yeah, on the test review sheet, there are 6 quadratic inequalities. For now, we'll just look at the first one. Well, maybe the first 2. When solving a quadratic inequality, we want one side to be 0, which we already have. Then the endpoints, we find the endpoints if by finding the x values that make the quadratic expression equal to 0. So find the endpoints of the intervals by solving the equation x squared minus 10x plus 21 equals 0. And we can solve this by factoring. So one of the factors is x minus 7, the other one is x minus 3. So the endpoints are positive 3 and positive 7. Okay, so what we usually do is we plot the endpoints. These 2 endpoints divide the number line into 3 separate intervals. And then we pick a test point from each interval. In the interval on the left, pick any number that's less than 3. So I'll pick x to be 0. And then in the inequality, replace every x with 0. We get 21 greater than or equal to 0. That's true. So all of the numbers from negative infinity to 3 are solutions. In the second interval, we'll pick a number between 3 and 7. I'll pick x to be 4. And then 4 squared is 16. And then minus 40. And then plus 21. So we get negative 24 plus 21 is negative 3, but negative 3 greater than or equal to 0 is false. So none of the numbers between 3 and 7 are solutions. In the third interval, pick a number greater than 7, like 8. Replace x with 8. 8 squared is 64. Minus 10 times 8 is minus 80 plus 21. So negative 16 plus 21 is 5. 5 greater than or equal to 0 is true. And we're going to include the endpoints because of the or equal to part in the inequality. So include the endpoints in the solutions. So the graph of the solution set, we put a bracket at 3 and shade to the left, a bracket at 7 and shade to the right. And then the algebraic notation, x is less than or equal to 3, or x is greater than or equal to 7. And then the interval notation, parenthesis negative infinity comma 3 bracket, and then union bracket 7 comma infinity. Okay, I'm changing my mind. Let's go to chapter 11 for now. Okay, find the distance between the points, negative 4, 9, and 7, 5. So I'll write down the distance formula. Make sure that you have this memorized, distance formula. Or if you don't want to memorize it, you can always derive it by using the Pythagorean theorem. But the distance between points x1, y1, and x2, y2 is the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Okay, so the given points are negative 4, 9, and 7, 5. So inside the square root, I'll pick negative 4 minus 7 quantity squared, and then plus 9 minus 5 quantity squared. And then we just do the arithmetic. Negative 4 minus 7 is negative 11. So negative 11 squared. 9 minus 5 is 4, so plus 4 squared. The number negative 11 squared is 121, and then plus 4 squared is plus 16. So we get the square root of 137. So the square root of 137 cannot be simplified any further. Part B is the same kind of problem as that. In part C, this is a circle problem. Write the standard equation of a circle centered at 7, negative 4 with radius square root of 3. So just to remind you in general, the standard equation of a circle is the binomial x minus h squared plus the binomial y minus k squared equals r squared. So the center is the ordered pair hk, and the radius is the square root of r squared. Take the square root of that number. Okay, so we're given the center, 7, negative 4, and the radius is the square root of 3. So we just write down x minus the x-coordinate of the center, quantity squared, plus y minus the y-coordinate of the center, quantity squared, equals the radius squared. And then simplify where we can. X minus 7 squared stays the way it is. And instead of y minus negative 4 quantity squared, we write y plus 4 quantity squared. And the square root of 3 squared is just 3. So that is the standard equation of the circle. Hey, we might as well do the next one. write the standard equation of a circle with center -3, 2, and radius 9. Okay, so the standard equation, x minus the x-coordinate of the center, x minus -3, quantity squared plus y minus the y-coordinate of the center, quantity squared, y minus 2 squared, and that's equal to 9 squared, the radius squared. And then we have a little bit of simplifying to do. X minus -3 quantity squared is x plus 3 quantity squared, and then plus y minus 2 squared. 9 squared is 81. Okay, on the next page, we have equations of circles, but they're not in standard form, and that's what we have to do. We have to write them in standard form. So we do that by completing the square. So x squared minus 7x plus y squared plus 5y plus 11 equals 0. So we start by writing x squared minus 7x. Leave a little bit of space before you write plus y squared plus 5y. Leave some space before you write the equal sign, and we're going to subtract 11 from both sides. Then we're going to complete the square twice. So on the left-hand side, we have to add 2 numbers, and then on the right-hand side, we have to add the same 2 numbers. But those 2 numbers are determined by what we get when we complete the square twice. Okay, so for this one, x squared minus 7x. To find the number that we're going to add to that to get a perfect square trinomial, we take 1/2 of -7, which is -7 halves. So maybe I can write this. 1/2 of -7 is -7 halves. And then we have to square that number. The number -7 halves squared is 49/4. So we're going to add 49/4 to both sides of the equation. And then we complete the square over here, y squared plus 5y. So this time we take 1/2 of 5, which is 5 halves. Then we square 5 halves, and we get 25/4. So we're going to add 25/4 to both sides. Okay, then we can get the standard form, x squared minus 7x plus 49/4. Well, we know we need a binomial squared, and we know that we need x inside the x is the first term of the binomial. So how do we know what follows the x? Well, what follows the x is what we got when we took 1/2 of -7. So minus 7 halves, x minus 7 halves quantity squared. And then for the other binomial, this time we have y squared plus 5y plus 25/4, which is a perfect square trinomial. So it's a binomial squared. We know the binomial has to have y. What follows y? The number that follows y is the same number we got when we took 1/2 of positive 5. So that means we're going to add y plus 5 halves. And then on the right-hand side, we just have to find a common denominator and do the arithmetic. So -11 over 1 is equivalent to -44 over 4. These other 2 numbers already have a common denominator, so 49/4 plus 25/4 is plus 74/4. And then when we add those, negative 44 fourths plus 74 fourths, we get positive 30 fourths, or 15 halves. Okay. So to clean this up a little, the standard equation is x minus 7 halves squared plus y plus 5 halves quantity squared equals 15 halves. Okay, the next one, graph the circle x plus 4 quantity squared plus y plus 3 quantity squared equals 4. So first, let's just identify the x and y coordinates of the center, and then also identify the radius. And then we can possibly graph something that looks sort of like a circle. The x coordinate of the center is negative 4. X plus 4 is the same as x minus negative 4. The y coordinate of the center is negative 3. And the radius is the square root of 4, which is 2. Okay, so if this is negative 1, negative 2, negative 3, negative 4, and so on. Negative 1, negative 2, negative 3, negative 4, negative 5. So the center, negative 4, 3, sorry, negative 4, negative 3. It's right here, that's the center. The radius is 2, so we can find points, a distance of 2 from the center on the vertical axis. As well as the horizontal axis. So roughly we get this circle. Okay, the next one, we've done things like this before. Write the circle's equation, x squared plus 16x plus y squared minus 14y minus 8 equals 0 in standard form. So we have to complete the square twice again. So we'll start by writing x squared plus 16x. Leave some space before you write plus y squared minus 14y. We're going to add 8 to both sides, but leave space before the equal sign equals 8. Then in the next step, we complete the square twice, once on x squared plus 16x, the second time on y squared minus 14y. So x squared plus 16x, we take half of 16 and square it. 8 squared is 64, so we add 64 to both sides. And then y squared minus 14y, half of negative 14 is negative 7. When we square negative 7, we get positive 49, so we add 49 to both sides. And then we can write the standard equation, x plus 8 quantity squared plus y minus 7 quantity squared equals 121. Yeah, so we have just a few seconds left. What's the center? And what's the radius? The X and Y coordinates of the center, the X coordinate is -8, the Y coordinate is +7, and the radius is the square root of 121, but that simplifies to 11. Okay, we had a pretty good sample of the test 4 review sheet. So tomorrow you can start the test as early as 7:45 a.m., but otherwise don't be late. That's all for today.